chapter, we will enhance our game logic to create a more interactive and challenging gameplay experience. We'll modify our current cube spawning and movement mechanics to introduce a stacking feature. Let's start by understanding the concept and plan our refactoring. Our current setup instantiates cubes that move to the right when a button is pressed. We aim to modify this behavior so that cubes will oscillate horizontally and, upon a button press, fall down and stack on top of each other. Each new cube will start oscillating from a higher position to avoid collisions with the already stacked cubes. First, we will modify our spawner script to keep track of the height from which new cubes will start oscillating. This will ensure each new cube spawns one block higher than the last. We will first add this line to define our height for spawning. Private float spawn height equals 1. Then we will increase the height after each instantiation with spawn height plus equals 1. Now we should add the spawn height variable to the our instantiate function by using it as the position's y-axis. Next, we will modify the move script to make the cube oscillate horizontally and fall upon a button press. We will copy and paste the code written in the resources. This code controls the cube's movement. Initially, the cube oscillates left and right between the screen edges. When the drop cube method is called, the cube stops oscillating, allowing it to fall with gravity. Since we do not want our cubes to have gravity at the beginning, we can go to Unity, unselect the gravity of the cube prefab if it is activated. Finally, we will update our button interaction to call the drop cube method on the currently moving cube from the spawner script. First, we will create a game object variable with private game object current cube. And then we will assign the instantiated cube to it by simply adding current cube to the beginning of the instantiate function. After that, for the button press, we will create a function called public void drop current cube. And call the drop cube function on the newly instantiated cube by writing this line. It is also important to add a null checker if current cube is destroyed or reassigned to another object with an if block. Now let's save. Go back to Unity. Set the spawn button's onClick event to call the drop current cube method before the spawn cube method. The order is also important. By doing this, these two methods will be called consecutively. In the first button press, thanks to the null checker, drop current cube won't be called. However, in the latter presses, both will run together. First, with the drop current cube function, the previously instantiated cube will drop, and later, with the spawn cube function, a new cube will start to oscillate. Spawn cube will also assign the game object for the next iteration, completing the cycle. Let's try and see if it will work. As we can see, cubes are instantiated very closely to each other. To fix that, in the spawner script, we need to adjust the height increment between each instantiate. We can try to increment the spawn height by 3. Save. And now run the simulation. We can now play the game as we are stacking the cubes. Now it is time to learn the tags. Tags are a powerful feature in Unity that allows you to categorize game objects and easily find or manage them in your scripts. We will use tags to manage our cubes, allowing us to create reset functionality where all cubes are destroyed and the spawn height is reset. Adding tags from the inspector has a few steps in the editor. Firstly, select the cube prefab in the project panel. In the inspector panel, click the tag dropdown and select Add Tag. Create a new tag called Cube. Now click the cube again and assign the cube tag to your cube prefab. Thanks to this tag operation, we will be able to find the object that has a specific tag in the scene from a script. We will destroy all cubes with another button press to reset the game. Let's create a new method in the spawner script. We can call the method as public void reset cubes. Then we will assign all the game objects with tag cube to an array by typing GameObject array cubes equal to GameObject dot find game objects with tag cube. The S in the objects is very important and usually confused with find game object with tags with an autocomplete which results in errors. Since we want to find all game objects with the tag cube, we use it as plural. Then we will iterate through the array and destroy each game object by typing for each game object cube in cubes. Destroy cube. Lastly, when the game is resetted, it is important to reset the spawn height as well, since we don't want to spawn the cubes from high up. Therefore, we will add spawn height equals 1. At the end of the method, We are done with our button interaction. However, we do not have the button for this yet. Save the script, and in Unity, create another button. We can place it to a left button this time. As in our previous chapter, we will click Alt and select button left from the anchor presets. Then we can adjust it a bit so it can have some margins. Let's create an on-click event on this button as well. And drop spawner game objects so that we can assign the functions we have written inside. Find reset cubes method and select it. Let's run the game and test. As we can see, we can instantiate and stack cubes by pressing the spawn button at the correct time. Also, we can reset the cubes and start all over again.